Hi everybody. There's one more thing I do want to mention before we close up here. Note that, at this point we have two methods of writing the equations of lines. We can use the standard form, which puts pretty much everything equal to 0, or put a constant on the right-hand side, and we also have y equals mx plus b, which is quite nice. A lot of people tend to use the slope-intercept form because, as noted by its name, it encodes information slope-intercept. So as you remember, m is the slope and b is the y-intercept. Now, this is all fine and dandy, assuming you have this information here. If you don't have the y-intercept, things can get kind of messy here, right? Because this b represents a point here. This represents this point where the line hits the y-axis here. But you may not have that information. For instance, let's say the point that you have here, even though we have a point and a slope, that's enough to determine the line. That point could be anywhere. So let's call this point x1 comma y1 here. And again, this line has slope m. We still don't know what's going on here because we have no idea where this point could be anywhere. It could be in any quadrant you want. So all we know at this point is we want to determine if there's another way to find the equation of this line here. So we could, in theory, use 0 comma b here and then do the calculations. But let's consider this here. Note that any other point on this line here is going to have the form x comma y. Now note that this is x comma y here. I write this as x1, y1. The subscripts represent the fact that these are constants. These are things we know. This is a fixed point. And this is known here. Whereas this here, can be any point. In theory, this xy can slide anywhere along this line here. It could be over here, it could be down here, or what have you here. Now, the only thing that we know is that the slope of this line is m. So we can use this here since we have 2 points. Let's go ahead and write this out here. So I can write, therefore, the slope of the line m equals, well, let's see. I'm going to write it as x. So remember, it's change in y over change in x. So it's going to be y minus y1 all over x minus x1 here. So notice that in this situation, we're just using the slope formula on this line here. So we can go ahead and put this together. Now, of course, we can sort of mess around with this here. This is a fraction. I'd rather not have the fraction here. So I can just multiply both sides by x minus x1 to sort of clear the fractions here. So I'm going to multiply this to get rid of the fractions. So when you do that, we're going to end up with the y minus y1 here. And that is going to be equal to m, which is the slope we had, times whatever's left over here. And that's going to be times x minus x1. So this here is another way to write the equation of a line here. We can see that this is a third way to write the equation of a line. Y minus y1 equals m times x minus x1 here. This, as you can see here, much like the slope-intercept form over here, which encodes a slope and intercept, it encodes information as well. We still have m is the slope here. So the slope is still encoded. However, the difference now is that instead of encoding a specific point, a point on the y-axis here, it encodes a general point here. In fact, it encodes this point here, x1 comma y1. So this is the fixed point, and that's x1 comma y1 here. So we refer to this here, what we have like this is known as the point slope form of the equation of a line here. Right? Note the blue y and the blue x here are just variables. They represent the sliding point, any point that's along this line here. Those are variables, much like how in the slope-intercept form, x and y are variables as well. They represent the structure of the line. The same is true here too. So note that we actually have many ways to write the equations of lines in the coordinate plane here. It's generally a preference as to how do you want to do this here. I think many people are going to be very comfortable with this, so there's nothing wrong with writing this here, but note that this is also perfectly valid as well.